let's continue our discussion on properties of logarithms. In a previous lesson, we already talked about the properties of logarithms that correspond to the first two properties of exponents. A to the power 0 equals 1. This is equivalent to log base A of 1 equals 0. And I can see this because my base to the exponent equals the argument of the log. So A to the power 0 equals 1. Similarly, for A to the power 1 equaling A to the power 1 equals A. We can rearrange the logs into their equivalent exponential forms. Now we're going to pick up 3 new properties, and they're all based on the properties of exponents. Logarithms are inverses of exponential functions. So if we have an exponential function that takes an input x, it will give us an output y. The input is the exponent. So when we look at log functions, log with the same base as the exponential will take the answer and give us back the exponent that it takes to get that answer. Now these two statements are equivalent in the sense that if I write b to the power x equals y, this is exactly the same as saying log base b of y equals x. And that's because my input and my output have switched. Remember that this is a trait of all inverse functions, that x comma y is an ordered pair on our function, then y comma x will be an ordered pair on our inverse function. And so that's why the roles of x and y have switched. 3 properties of exponents that we have. The first one, if I have a to the power m times a to the power n, I really just need to add the exponents. And this comes from the idea that if I had 2 to the third times 2 to the fourth, if I write them all out, 2 to the third times 2 to the fourth, I see that I have 3, 4, 5, 6, 7 total 2's that I'm multiplying together, and so this would be 2 to the 7th. But 3 plus 4 is 7, so I can add the exponents together. Because logarithms are exponents, if I'm multiplying inside the log, then I can break that apart with addition. Remember that logs are exponents, so I'm asking what exponent of a will give me m times n. And that exponent will be the exponent that gives me m plus the exponent that gives me n. So that's our first log property. Multiplication inside the log becomes addition outside. So we can break one single log into 2 logs with a sum. Multiplication means we add the exponents. Division means we subtract the exponents. I can play kind of the same game, 2 to the 4th divided by 2 to the 3rd. And so I put 4 2's multiplied together on top, 3 2's multiplied together on the bottom, and I can cancel common factors, and I'm left with 1, 2 to the 1st. But 2 to the 1st is equivalent to 2 to the power 4 minus 3. I can subtract the exponents. So if we're dividing inside the log, that means we can subtract log of the numerator minus log of the denominator. And then our last log property, if I take a base to an exponent and I raise it to another exponent, I'm really multiplying. An example here, we'll use the same numbers as before. 2 to the power 3 to the 4th means I've got 4 2 to the thirds. But I notice that if I have 2 to the third times 2 to the third times 2 to the third times 2 to the third, well, I could just use that third log property up here that says multiplication means I add the exponents. 3 plus 3 plus 3 plus 3 will give me 12, but 12 is also equivalent to 3 times 4. We can multiply the exponents if we're raising an exponential expression to another exponent. And we did a lot of practices with exponents back when we talked about radical expressions and radical functions. So these properties of exponents are the same ones that we talked about before. And we have the corresponding log function. If I have an exponential expression, the exponent here can be pulled out in front of the log. So we can simplify this exponential expression into multiplication. Now these are pretty powerful if you think about it. Log takes multiplication and turns it into addition outside. Log takes division and turns it into subtraction It's like we're knocking that operation down a peg on the order of operations. And then it takes exponentials and turns it into multiplication. So using logarithms in other situations can actually make solving things a little bit simpler, a little bit easier in some cases. We do not have properties if we have a sum or a difference inside the log. And we do not have properties for division or multiplication outside the log. The division property here is our change of base formula, which would equal something completely different than this log base b of r over s. The change of base formula, log base b r over log base b s, would be equivalent to log base s of r. So very different from what's given here, which is why these not equal to's are nice and big. Highlight them. These are not equivalent. We have no properties for these. There are no analogous exponential rules that allow us to do anything with addition with exponents, subtraction with exponents, and then dividing and multiplying outside of logs. Again, no exponential properties that'll allow us to do that. Let's look at some simple examples. So a first one, log base 3 of 27, we can think of 27 as 3 times 9. If we think of 27 as 3 times 9, then we can break it apart with addition. Log base 3 of 3 plus log base 3 of 9. Well, log base 3 of 3, according to that second property, is 1. What exponent of 3 gives me 3? That exponent is 1. And then what exponent of 3 gives me 9? 2. And 1 plus 2 is 3. To check this, sure enough, log base 3, 27 will equal 3 because 3 to the third power is 27. And so it makes sense that it works. And I'm going to color this slightly differently so you can see where the 3's are coming from. The base in the log becomes the base in the exponent. We can also consider a division or subtraction property. And I am using very simple numbers here so that it's easier for us to see both sides of it. So log base 4 of 64 divided by 4. Well, 64 divided by 4, that's going to be 16. And log base 4 of 16, what exponent of 4 gives me 16? 2, because 4 squared will give me 16. But let's see how I use that division to subtraction property. So we're dividing inside the log, which means we can subtract outside. And log base 4 of 64, what exponent of 4 gives me 64? That exponent's 3. What exponent of 4 gives me 1? That exponent is 1. 3 minus 1 is 2. And we already said that 64 divided by 4 will give us 16. Log base 4 of 16 is 2, and it works. And then the exponential property, log base 5 of 125. Maybe we know that 125 is 5 to the third. So then for this property, we can take that exponent 3 and bring it down. Log base 5 of 5 from that second property is 1, because 5 to the first power will give us 5. And 3 times 1 is 3. Also notice that log base 5 of 125 is 3, because 5 to the third power is 125. So just showing how we can use these properties to create problems that aren't quite as complicated. Addition is a little bit easier to handle than multiplication. Subtraction's a little bit easier to handle than division, at least mentally. And multiplication's a little bit easier to handle than exponentiation. And so logs help us break it down into a little bit of a simpler problem.